Let's see. First off, 2 weeks from tonight, on April 3rd, I won't be here at the Wellington campus. I plan to broadcast the class from home via Zoom. That's my current plans. Or what? April 3rd, yes. My son's having surgery on April 2nd, and they said he can come home on the 3rd. Usually that means not early in the morning, but like sometime in the afternoon, typically. If you do not see me get on, that means that there's some kind of complication, and I'll put an alternative activity out there. I'll mention that next time also, just so you're not kind of unaware. This is chapter 8, C characters and strings. Okay, in this chapter, we'll use the functions of the character handling library, the ctype.h. We'll use the string conversion functions of the general utilities library, the standardlib.h. Use the string and character input-output functions of the standard input-output library, the stdio.h, standardio.h. Use the string processing functions of the string handling library, string.h. And use the memory processing functions of the string handling library, the string.h. And that's just kind of an overview, what we'll be talking about. You've used some of this already. Some of the formatting of printf, where we could print like a string. So we've seen that. So this is working with characters. So you got single characters for single letters for characters, and then you got an array of characters for strings. Characters are the most fundamental building blocks of source programs. Every program is composed of a sequence of characters that, when grouped together meaningfully, is interpreted by a computer as a series of instructions used to accomplish a task. Program may contain character constants. Character constant is an integer value represented as a character in single quotes. The value of a character constant is the integer value of the character in machine's character set. Gets a little bit confusing. If we look at our ASCII table, you got different letters out here, but we're going to see that letter corresponds to a number. So it's not like what you might think in other programming languages. That's what they say. A character constant is integer value, represented as a character in single quotes. For example, little z represents the integer value of z. You see in the ASCII table here, the little z is decimal value 122. So when they're talking about the correlation between z and 122, that's what they're talking about. The /n, the new line, I think, or I don't think that's carrier return. I think that's new line, is 10. I lie. 10 is, oh no, new line. Yeah, new line, or line feed. So again, those correspond directly with the numbers. And a string is a series of characters, treated as a single unit. A string can have any letters, digits, and various special characters. String literal string constants in C are written in double quotation marks, and we'll see all that. Now, your array of characters for a string has to end with this /0. That's what terminates. That's how C knows that we're at the end of the string, the array of characters. String is accessed via a pointer to the first character in the string. So we talked about arrays before where we had a pointer pointing to where it starts. Kind of the same principle here because remember string is an array of characters. Doesn't see it's appropriate to say that a string is a pointer. In fact, a pointer to the string's first character. In this sense, strings are like arrays because array is also a pointer to its first element. That's what we just said. Character array or variable of type char with asterisk can be initialized with a string in a definition. So this is what we're talking about here. So we got our char and then color and then our beginning bracket, closing bracket equals blue. Where's the bracket go? Color equals blue, was it? Yeah. Well, let's see. I think it's %C for a character, but we'll see. Assuming I remember the format specifier. See how it returns B. Because that's my first letter. And again, the numbering on this always starts at 0. That's my 0th entry, first, second, third. So to loop through there, I would go from 0 to 3. If you remember a for loop, int x equals 0. For x equals 0. Continue while x is less than or equal to 3. X plus plus. And then if I do printf %C /n. And then what'd you say? What is a /n? I should go to the next line. And you see it does blue. Let's change this to 4. And assuming I wasn't still running it. There we go. Let's go to 40. Nowhere do you see an error. Other programming languages would give you an error if you tried to go beyond the length of the string. C is a little bit lower level in that regard, and you see it's just accessing memory. That's why it's so important that you check for this right here, if you don't know how big the string is to begin with. Now this defines the same way. So this would define color pointer equal blue. So just different ways of representing it. Personally, I like this one. So I always get these confused. I forget whether to put an asterisk on here or an ampersand or what exactly. Okay. Preceding array definition could have been written this way. So we got that that method. We also have this, where you put your curly brackets around it, and then each one of these is a single character. And notice that the ending one here is our /0. So both of those accomplish the same task also. Again, they'll emphasize this over and over. You have to have that terminating null character at the end, as it tells it to stop. And that's how we'll see the loop later on, is how you can loop through it without hard coding a value in. Not allocating sufficient space and character array to store the null character of the terminating string is an error. Yeah, it's an error, but it's not a. It's just your program's not working correctly, so it's not a compile time error. So it's not going to stop you there. It's actually not even going to give you a runtime error; it just won't work. So it is an error. I'll give them that. Printing a string that does not contain a terminating null character is an error. Okay, be sure it's Now notice here, characters beyond the end of the array will override data and memory following the array. Now, probably that's not going to cause you too much trouble anymore. When you look at the memory allocation, they've set aside portions of the memory for the Windows operating system. Well, there's portions of the memory for the lower level, the machine level. But they've set aside a portion of the memory for the Windows operating system. And I don't think, and I'm not a hacker, so I'm just speaking out of turn here, but I don't think there's any way you could overflow your memory so it goes into the memory reserved for the operating system. Doesn't mean it wouldn't necessarily do other damage, would open up other holes, but I don't think it would do that. Typically when that happens, like your system crashes and so forth. Didn't used to be that way. It used to be you could, with earlier operating systems, cause your operating system to crash pretty easy by doing that overflowing. I say pretty easy because it seemed like I'd lock my machine up fairly often by not coding correctly. Not because I was trying to do it, but it was just like the machine kept locking up. A string can be stored in an array using scanf. And how we do that is with the %s. Let's see, what do they want there? Word 20. Scanf, %s, and word. And got too many curly brackets. There we go. We got David. If you try to do a printf, let's see what happens. Prince David, just what you'd expect. David space Hayes, just Prince David. So yeah, it's kind of works. I mean, there's ways around that, but the space that's in between David and Hayes, it thinks that's two separate inputs you're passing in, so it ignores the Hayes part. They point out you do not need the ampersand symbol because it's an array. It's an array of characters, which means it's already a pointer, so it's pointing to that. So it's different than what we did before. I think it would give you an error if you put that on there. Maybe, I don't know. Never have tried. If you forget and put it on there, let's see. Still works. So, it's just not necessary because it's already a pointer to the beginning of the array. Here's what I just demonstrated. Scanf will read characters till a space, tab, or new line or end of file character is encountered. End of file. I think that's Control C, but I don't know. I think it is in Linux. David, Control C. I don't know. I didn't watch it fast enough. But anyway. Let's see. So it's possible without the field width 19, the conversion specifier, percent 19s, the user input could exceed 19 characters and the program might crash. We don't got a kind of specifier here. So let's see. The dog was sitting at the door waiting for someone to come home. Boy, I'm really bad there. So looks like it worked there, but look at my process return. That's kind of a weird number to return. Let's see what it would return. Well, I don't even got to return. Never mind. I'll return 0. So that number coming back meant there was probably some kind of error. That's why, in theory, you should have your return here to indicate that it's successful. Or if there's other things you want to pass back, then you pass that back. Let's see if they put 19 in. See what happens. The dog sat by the door waiting for someone to come home. Notice this time it returned 0, and it cut it off. So this is where it appears like you could just leave the number off. It works just fine. But really, it opens up to potential problems. And maybe that's how we'll see the security notes at the end, but maybe that's how hackers could learn to get into your program. Most important of all, it says it saves the last character for the string's terminating null character. So you have to have that /0. Otherwise, it doesn't know where to end. For read and input lines of arbitrary length, there's a non-standard yet widely supported function readLine, usually included in the stdio.h. For a character array to be printed properly as a string, the array must contain a terminating null character. Bring that in. So, readLine. I wonder what the syntax is on it. I don't know. All I can think of is C# right now. For a character array to be printed properly, okay, we talked about that. Okay. Processing a single character as a string is a pointer, probably a respectable large integer. However, a character is a small integer. ASCII values range 0 to 255. Again, that goes back to here. 0, 127, and then our extended goes up to 255. So if you wanted to print these characters here, then you'd have to access your extended ASCII codes. This was exciting times back in the late 80s. We obviously didn't have much of a life then, because people learned what they could do with these extended ASCII codes. And so mainframe reports all of a sudden had borders on them. You have a border around a report, and you'd spend a week getting that silly border on that report, and the user would get, wow, you got a border on it. It's just like, no practical value. But if you use these characters correctly, you can create like the box around whatever. So. I'm thinking that this is not consistent across all platforms, but I'm not for sure about that. I'm not sure if I know the standard is, the ASCII up here, but I don't know if you went off to like a MacBook or something like that, if you try to use these, if you come up with the correct ones or not. Let's see. Many systems cause an error because low memory address is reserved for special purposes, such as operating system interrupt handlers, so access violations occur. I wonder what causes an error. Processing a single character as a string. I don't think I ever tried it, but I don't know why I would. A. C. I have no clue. Most times your memory doesn't go that small anyway, and you'd really have to confuse your the memory address with the actual value to screw that up. What they're talking about. What windows do I have open? Okay. Is the memory here like F0, F00A type of deal. Down here 176. So if you had 176, whatever that is in ASCII, and you got confused on it, then I think that's where you could crash it. But if you're doing it properly, I don't see why in the world a single character would cause you issues. Passing character as an argument to a function when a string is expected is a compilation error. That's kind of... if you're over here using S versus using C, one of them is expecting a character. Character handling library ctype.h includes several functions to perform useful tests and manipulations of character data. Each function receives an unsigned character or into file as an argument. Into file normally has a value of -1, and this is summarized in this. Is blank. Returns a true value if C is a blank character. Now you see what it's returning. It's returning an integer. is digit. Returns true if C is a digit and 0. False otherwise. Is alpha. So if I was bringing in a character, I do an if. Let's see. Is alpha. Word equal to 1. It has an alpha. We'll see if I got the syntax correct on that function. They're not as intuitive as other languages, I don't think. 3. Didn't like something there. Nah, I got something wrong with the. Why didn't give me a compiler? Implicit warning. Implicit declaration of function is alpha. It's a library. Character handling. C type. Well, helps if I actually bring it in. Okay, so A. Still doesn't like something there. Equal to 1. That'll probably give us an example soon. If not, I'll Google it and find one. Anyway, is alphanumeric? Is X digit? What's X digit? Hexadecimal digit character. Is lowercase. Is uppercase. 2 lower. This returns as lowercase. 2 upper changes it to uppercase. Let's see. Is space is control. So control character. Is punctuation. Printing. Is print returns true if it's a printing character. Is graph printing character other than a space. So most of these I've never used. Let's see if we can find an example of that one. Is alpha. It could be because I declared it as an integer or a character. I may just try to change that before I even. Let's try that. Nope. Okay. C programming is alpha example. Tutorials point is a pretty good one, usually. Okay, character C. I see what I did wrong. Forgot to put that ampersand. Remember, the only time you can leave that off is when it's actually in a string, an array of characters, or an array by itself. Okay. Yeah. No error that time. Just didn't work. Okay, so let's see what else I'm doing wrong. Bring that in, %C. And %word. If is alpha is equal to 0, it's not an alphabet. That is weird. Let's cheat. Inner character A. A is an alphabet. Scanf. Printf shouldn't matter. %C. &word. If is alpha word equals 0. Maybe it's never equal to 1. I assumed that, but 0. It does not have an alpha. Else, printf, it does have an alpha. It does have an alpha. Does not have an alpha. So what in the world is it equal to? I assume true was 1, but maybe that's not accurate. Printf %d/n is alpha word. ID returned exit status %d/n comma. You mean you won't let me put that there? This equals is I spelled something really off earlier today. It just wouldn't run. Okay, so 3 does not have an alpha. A 2. So if I check to see if it's equal to 2, it doesn't say returns 1. Just says returns a true value. This is where, if you go into programming, you should be patient. You should dig around, try to figure out what's going on with it. I wrote a program earlier today in C# where I brought in I wrote it to a CSV file, and then I took that and I loaded it into Excel from within the C# program. Had no clue how to do that when I started. Hadn't done that in a long time, so I Googled it, and there's a lot of web pages. There's 2 web pages I use. One of them was Microsoft's web page. You'd think Microsoft would work, but it didn't. But I took part of Microsoft's and I took part of theirs and combined them together and was able to figure out the solution to it. Sometimes you get ideas just from looking at people that don't know what they're doing, as myself. Normally, you don't like to go to the one that says, I don't know, Stack Overflow or whatever that website is. That's where people go and try to get help. Like here. I try to avoid that to begin with. But if I get desperate, then I go to Stack Overflow just to get ideas. Ones I've been finding very useful lately is this Tutorials Point. That seems to have some pretty good examples. Okay. And talked about somewhat about those. I'm not going to go into all those. This talks about the program demonstrates these. Function is digit, determines whether its argument is a digit, 0 through 9 is alpha, uppercase A through Z or lowercase a through Z. Let's bring in, make it an integer. And printf %d/n and then word. I'm curious what this will do. I typed little a in, it came up with 97. Little a is decimal 97. What you'll find, it gets confusing when you're working with characters, because I declared this as integer, didn't I? Integer is a number, no decimals. Then all of a sudden I willy-nilly put a %c here. %c is bringing in a character. But then I flip back and I put a %d here. And well, let's see what happens if I do a %c. Assuming I wouldn't still run the program. There we go. So when I put A in, it gives me 97 and gives me A. So you can see that there's a real close connection between the integer and a character. There's even a corresponding value here. For example, if you look at the difference between little a, which is 97, and big A, which is 65, that's a difference of 32. So I'm guessing on this one even, maybe. Let's see if this is true, because I don't know. I can say word is equal to word minus 32. Let's see how that changes it, if it'll allow me to do that. By subtracting 32 from it, it made it uppercase. And that's true with any character you put in there. If I ran this and I put B in, subtracting 32 gives me big uppercase B. So some people use that to do the conversion from lowercase to uppercase. They don't use one of those functions we saw. Let me see. Is alpha numeric? Is either a number or a letter? Is X digit? Is a hexadecimal digit? A through F, little a through F, and 0 through 9. With hex, it only goes up to F. So it goes 0 through 9, then 10 is A, 11 is B, 12 is C, 13 is D. Anyway, it goes up to 15. Doesn't go to 16. And 15 is F. That's why they have that there. And this shows you some examples there, but I already demonstrated one of them. So. Notice J cannot be a hexadecimal digit because it's not valid. I don't really like this format. If you like that, you can use it. This is like a strange if-else statement. Oh, there's more. It comes after. But this is like this checking this if statement here. It's asking if this is true. If this is true, then it does this. If this is false, then it does this. So again, I don't like that format. I think it's confusing to look at, but if you like it, then use it. If you're an engineer type, you probably like things really concise. You don't like wordiness. Does it run any faster? No. It's the same speed as the other one. Okay, and this demonstrates is lower, is upper, two lower, two upper. Now, two lower and two upper, what do you think the only thing that those pieces of code are doing? They're doing uppercase and lowercase, and what are they doing math-wise? Yeah, just adding, subtracting 32. So they're easy bits of code. They just try to present it in a little more friendly format by having functions you can call. If the argument's not an uppercase letter, two lower returns the argument unchanged. Because if you have, for example, if you start out with uppercase A, and you want to change that to uppercase, and if we said going from little a to big A, we subtract 32. If I subtracted 32 again, 65 minus 32 is 33. 33 would take it to an exclamation mark. So it does a little bit more than just adding and subtracting, but there's an if statement involved. Like this right here. We said that this would make it uppercase. But if it's uppercase to begin with, if I put uppercase A in there, it returns an exclamation character. Exclamation. Let's say I put space in. Space is 32. 32 minus, am I subtracting 32? I'm subtracting 32. Never mind. I don't know how to put any of these in. Bell, backspace, horizontal tab. Might be able to do that one. If I do tab, press enter. Negative 23 and 0. I don't know what that is. Anyway, you just need to know which way you're going, basically. The function takes that out of your hand, so you don't have to worry about it. Again, to get my ASCII characters here, I think there's a smiley face somewhere. Maybe I'm lying. Yeah, I must be making it up. I don't see no smiley face. Must be thinking of Facebook. If I do the 142, if I go ahead and bring that in, but then I go ahead and change it to word equals 142. Whatever I type in. See how it does a little A with a is that 2 dots over it, I think. My eyes are seeing that. So that's how you could sit there and get the top row here. For example, if I was wanting to print a corner, a single line corner, probably looking right at it. Here it is, 218. So if I do a print on 218, let's see, do I want to print decimal or character? I think character. 218. Does my upper corner. Then, if I wanted to loop for, I don't know if I can declare that. I'm getting the languages mixed up. X is less than or equal to 50, X plus plus, printf %c/n, and then I'm going to print the line, I think 196, and run that. That's interesting. Oh, no /n. That wasn't right. No /n. See how it's printing the box now? We had to do this on some printers, and we had to do it on it was a Zebra label printer. Hated that printer. Very nice printer. We bought these labels you put on the back spectrum analyzers, but you couldn't print to it from like Word or anything like that. You had to print to it from your program. And so you had to explore all these codes you had to pass in. And there was even more extended ones than the ASCII ones. So you could do barcodes and everything. And pain, I hate working with printers. But that's what you do is you'd explore the codes and then you would keep practicing over and over until you got it right. Okay. And you can read about those. Checking for special characters, white space characters, horizontal tabs. So all the different things you can check for. Punctuation characters. For the most part, you never work with many of those. Uppercase and lowercase is a common one. I was looking at a problem earlier today in Blackboard. Another instructor had. It was counting some problems wrong. And the only thing I could figure, and I would assume Blackboard would have handled this, is he had put carbon in his key in fill in the blank, and the student had put carbon with the lowercase c. String-wise, those are completely different because this is little c, this is big C. And over here, if you're doing a comparison and comparing big C, which is 67, to little c, which is 99, then they won't match. So then I told him, well, change it to little c. Let's try that. That still didn't work. So I don't think we ever did figure out what was going on with Blackboard. Blackboard's just got some issues with this grading and so forth. But those are things you have to consider. Do you need to change everything to all uppercase, all lowercase? Let's see. C1, C2, scanf, %C, C1, scanf, %C, C2. Something's wrong there. Why is the spacing off? Okay, so bring those in. And if C1 is equal to C2, now printf, they are equal, /n, else printf, they are not equal. I'm deliberately writing little bits of code here for a reason. There's a test out there now in Blackboard under the current week. It's a programming test. There's 3 questions to it. It's timed, so don't go open it up to see what it looks like. You got 80 minutes for it. 3 questions, each one's worth 60 points, and they're based upon programming constructs. One of them is an if-else statement, one of them is a for loop, one of them is a while loop. I haven't shown you the while loop yet, but somehow integrate while into one of these examples to refresh your memory. They're not extremely challenging. I'm not going to ask you to print to a Zebra printer and have the barcode. The if-else, the for loop, and the while loop. And I don't normally like tests in programming classes. I don't think they're really that meaningful. Be able to regurgitate a definition doesn't mean you can program. Had a person that she started at Koch Industries. I went to school with her, actually. And she graduated top of her class. A's in every class. I forget what that's called. Obviously, I didn't graduate that way. Is that what it's called? Okay. She graduated that way. Went to work for Koch. And she had focused strictly on computer science classes that really were definition-based. And she was very good at that. She had a very good memory. I have a poor memory. I'm more of the I can code something type of person. And she lasted maybe about 2 months, and then Koch fired her. She could not program. Here's a woman graduated top of her class, but she could not program. So that's why that's why my classes on programming focus almost exclusively on programming. This is for accreditation purposes. They require us to have program level outcomes, PLOs, and it's just to have some kind of measure of students coming out of your program. What did they learn, type of deal. And so it's what? No, I don't know where she ended up at. I'm sure she really was successful at whatever because she's very hardworking and sharp. It wasn't like she was lazy or anything. She just couldn't program. And you can do that. There's computer science degrees you can go where you can take all these classes that are really not very heavy into programming, and you graduate with a computer science degree and not know how to program. course, if you're going to go for a programming job, you're not going to last very long. So I always tell people, take as many programming classes as you need to get that comfort level down. Might be one class, might be 5. That's not something I can tell you. That's something you got to feel yourself. It's like if it's just flowing and so forth, then you're probably fine. If you're sitting here and it's like going through mud, to write a program like this takes you 3 hours. You need to take more programming classes. There's no other way around that. Okay, now let's see if this will work what I have in mind. And this demonstrates an if else statement. C, that's nice. I didn't put 2 in. They're not equal. Scanf, %C. Now that I bragged how good a programmer I am, I can't program. 3. What am I missing? Let's see, that's 39. So let me go back to where the scanfs are. Oh, maybe it's because I have them as declared as integer. Well, let's try a character. Okay. Here. I'm here too. And here, I'm here too. They're not equal. Anybody see what I'm doing wrong? Won't even let me do the next scanf. Three in. 4 in. Okay, it's a %C. So what is the format specifier for a character? Let's see. C programming format specifiers. %C is a character. Geeks for geeks. character input. That's what I got, I think. char ch scanf %c little ampersand. %c ampersand ch2 %c ch2. Okay, C. It's not allowing me to do two of them at once, is it? I have to think about that one. Huh. Well, I'll hard code it and show it. If it'll show what I want it to show. They're not equal. See how this is little case and that's uppercase. And it says they're not equal. So, again, big thing in programming. I have to puzzle over that one. Okay, we got some string conversion functions. These functions convert strings of digits to integer and floating point values. Because you bring in a string, and maybe you want to convert it to a number, so you can work with it. And we're going to see a bunch of libraries for that. And you can kind of look at the name and tell what it's doing. str string to d for double. So this will take, and you see here that it's converting a string in pointer to double. So it's not converting a single character, it's converting an array of characters, or a pointer. Here we got string to L, string to long. So converts that. String to unsigned long. Now again, this tells you what to expect. This says it should be a double, and this says I'm passing in an array of characters. String to, or str to d, string to double. Converts sequence of characters representing a floating point value to double. Returns 0 if it's unable to convert any portion of its first argument to double. Function receives two arguments, a string, the character, then the asterisk, and a pointer to the string. String argument contains a character sequence to be converted to double. Any white space characters beginning the string are ignored. And I'll show you this example here, which will be more meaningful than this. But you see there's two parameters coming in. Our string and then the pointer. How did they make that an image so I can't copy it? Let me type the relevant parts in. So we got constant char string equals 51.2 percent are omitted. And double D char string pointer D is equal to string to D of string, comma, and then our string pointer. And printf percent the string percent %s is converted to the next line. Just curious. Is nothing passed in? Oh, string's passed in. String. And printf double value percent dot 2f and the string slash there percent %s slash quotes slash in comma D comma string pointer. Okay, the string 51.2. Now, if you're wondering what that slash in the quotes double quote is if you want to embed a double quote inside of a string, you have to put that slash in front of it. That tells it that the next character we're just going to print as is. It's not ending the string. Then percent %s is coming in from string, and then that's comes from this right here. Is converted to the double value 51.2. That's our D. So what did it do with stuff that wasn't a number? Just dropped it, didn't it? I think I got something wrong there. Slash double quote percent %s. Oh, that's the part that got taken off. If I put a in here, let's see. I'm guessing what it'll do is 5 will be the double, and then the rest will be referenced by our string pointer. Let's see if I'm right. Double value is 5, and then the rest is that. So the first the first character run across that's not a number or part of a number like a decimal causes it to fail for all the rest. This one converts it to a long integer. You see here we got our string, and then we got the negative 1 through 7 digits, then ABC. This that gives us. Convert value is negative 1, 2, 3, 4, 5, 6, 7. And the remainder of the string is ABC. Then you add 567 gives you that. I think they're just demonstrating it's actually a number you can work with at that point. What I was curious about is what it would do if you put a number that was too big. Because the long integer only goes up to a certain value. What it does then. I really don't know the answer to that. Unsigned long integer. Okay, so again, got the mixture of a number, no sign, no, and ABC. And see, the original string's at, it gives you the number until it's the first non-numeric or decimal even, because this is an integer. And then the rest of it's just referenced with that pointer. Grab a drink here. Those making sense on those libraries? Okay, this talks about our standard input-output library, STDIO, standard in-out. Get character, get char. Inputs the next character from the standard input, returns it as an integer. Again, it's getting a character and converting it to an integer. Here's a char, and then we got our asterisk f gets. Inputs characters from the specified stream into the array S until a new line or end-of-file character is encountered, or until n-1 bytes are read. In this chapter, we specify the stream as standard in, the standard input stream, which is typically used to read characters from the keyboard, or terminating null character is appended to the array. Returns a string that is read into S. Got a put character. Prints a character shortened C, returns as an integer. A with a tilde. A with a, if that is a tilde, I don't know what it is. I never have understood the need for this one. Bell. That's 7. Nice bell, though. Let me do a while loop. Here's a place to incorporate that. I want 5 bells. Remember, with a while loop, we have to initialize our value outside of the while loop. So I set x equal to 1. And I'll say while x is less than or equal to 5, then I'm going to do some lines of code. And you need to increase x within your while loop. So you got 3 parts to it. You got your initialization part here. You got your Boolean check. And then you got your where you're increasing it by 1. Now, if I do a print on x, let's see what it prints. That's disappointing. There's only 1 bell. It prints 1 through 5. Maybe because it won't do another bell until the other one's finished. Sure enough, only does one bell. Most of the times when you're programming in C, not always, but a lot of times when you're programming in C, you're not worried about putting bells into it. It's not like a GUI. It's not a graphical interface. Although you can get some ones that have a graphical side to them, but your standard one isn't. Let's see. Put S as a string, puts a string S, followed by a new line character. Hello, everybody. Prints hello, everybody. Now you notice what I've been doing. What have I been doing wrong? I've like screwed up at least twice, if not 3 times. Probably more than that. That's just the only ones I know. Look what these are defined as. They're defined to return something, and that's an indicator if something's gone wrong. By me ignoring that, that's a potential hacking place where somebody can overload it in some manner and perform their magic. I'm just slopping it down there, but that is something you'd want to consider if you're trying to write code that the external world can possibly hack into. Then you want to handle that. I don't really know how you could screw up a put S, though. How it could return anything but success. Because I think if you tried to pass in something that wasn't a string, I don't think it would even get that far. I lie. Process returned. So if I had this, status equals put S, and I print this, printf %d/n status. It doesn't even get that far where it prints what status was. Well, let's put something in there that works and see what it is. Hello world. Well, that's really bad. Return 0. 0 is our indicator, it was successful. So if I don't know how you could screw it up where it returns invalid status, because I was putting a number in there and just wouldn't return anything. But. Okay. sprintf, the equivalent to printf, except for the output is stored in array S instead of printed on the screen. So it looks like if you wanted to print it to the array S, then that's how you do it. And this, equivalent to scanf, except for the input is read from the array S rather than from the keyboard. See, this talks about fgets and put character. So I got a sentence here. It's an array of characters with a size of 80. I do a put S, enter a line of text. the fgets here is going to read in a line of text. Now, if I remember right, the fgets does not have the problem with the space like we saw earlier. But let's test that, see if I'm right. My memory is always suspect. Sentence. And size. Actually, we just hard code 80 in there. Okay. And now I do fgets. Sentence. Comma size. Standard in. And printf percent or put s, I guess I could do. Sentence. What if that'll work on an array of characters? Yeah, it should. Fgets sentence size. David Hayes. See how it doesn't cut off the Hayes part? That's what I was talking about earlier. There's different ways of getting your input in such that you can have spaces. You may be saying, well, why do they have the other way then? Well, if you want to have spaces to delimit your different array of characters, then that's a way you can have it split it apart. For example, if you had first name and last name arrays of characters, if space splits it apart where it puts it into the other variable, then you could code it around that. And I have no clue what this one does. Reverse. No, reverses characters. Using recursion. That's interesting. Recursion is typically something you want to avoid, but it could be... I could write this differently so I wouldn't have to use recursion. Because it's just an array of characters, so you could go backwards or forwards, and then just write it out accordingly to a new string, new array of characters. Part of the problem is I caused it to crash earlier because I wanted to see what it would do, see if it'd lock up my machine. It doesn't, so I was happy about that. Void run it. Run it 3 and int num. Except for up there, I just want to prototype. What am I doing? Void run it int num. And then run it 5 or whatever. Oh, that's disappointing. It still crashed. But C# I think is what I did it in earlier because I wanted to see what the error code was. And it overflows something called stack. Stack is when you do a call to a function, to a method, it's like a piece of memory that it pushes down variables and register entries and so forth. Keeps track of all that. And if you push down too many times, it'll be a stack overflow. This doesn't tell us stack overflow, but that's what happened. So that's why I don't like recursion. Causes too many headaches in the long run. But there's sometimes where you have to do it. Especially if you're writing a system utility for Linux, for example, and you're trying to recursively go through all your directories. There's no other way around it besides recursion. Here's a get char. Put S to read characters. Now this has a loop in it. When you use the get char, it's getting a character at a time. So here's a put S, enter line of text. I got my while I is less than size minus 1. Why size minus 1? For an array of characters, what does your last character have to be? /0. So that's why they're making sure that there's enough space left for that /0. And then it's going to get character and assign it to C and continue while that's not equal to the /n, the new line. So this gets it a character at a time and builds it into this array of characters down here, the string. And you notice the I++. There's a lot of shortcutting here. The I++, instead of saying I equals I plus 1. That's probably the easiest way to put the get char up there, but it just seems strange when you see it. Although you can't really see it with this to test, they're typing T in, and that's getting one character. So that's one looping through here. So this get character is just getting one character at a time. Then they now type the H, and it gets the H. So that's another loop through the time through the while loop, and so forth. I used that principle there, the get character, when I was writing a bunch of that bar coding for the production floor at IFR. Because when you're scanning that in, I'd mentioned this before, the barcode started with like .wo. And so I wanted to get a character at a time. So if they put a dot in, then I knew it was a barcode. And so then I started, I put a flag like barcode equals yes. Or true, or what, I forget what it was I did. And then I started looking for other characters. The next two characters, if it said W and O, that was a work order. And I threw the WO aside because I didn't want to write that out to the database. And then the next part of that I knew was a work order number. And so then that got stored in the database. I use that plus case statements to simplify the code. But I use get char there. I suppose you could. I don't really know why I did it that way. Boy, that's sad. I've forgotten why we coded that way. Because you think, well, why don't you just bring it as a string? Bring it as a string and then check to see if your first character is a dot. If it is, then see what type of string it is. If it's a work order, purchase order. Must have been a reason. I didn't do it the hard way. Usually the easy way is the way I always go in programming. Of course, I don't always see the easy way, so that's another thing. Okay, sprintf. We talked about that. No, we didn't talk about that. Yeah, we did. To print formatted data into an array. So we got our array of characters up here, S. It's got a size. And then down here, the sprintf, integer colon %6d. Okay, so it's taking these values up here that they input and building a string out of it. So when this gets done running, the array of characters, S, should contain integer colon, whatever's input in for the integer, new line, so next line, and then double, and then %8.2, and then F. And that's weird. No new line at the end. Does that seem weird though, that you can put a new line right in the middle of a string? Remember what new line is. It's nothing special. A new line is just a character. It's over here. I used to have those memorized, what new line was. It's a decimal 12. And this shows you the format. It shows that when you print it, it puts it on 2 separate lines. So if you want to do that. And we've been going about an hour and a half, so that's probably not a bad place for a 10-minute break. And then we'll continue on. flush. But the use of his voice is determined to be undefined. Standard in. C. There it is. Although I didn't remember the exact syntax, reason when you do the scanf here and you do another scanf with the character, you have to flush the buffer. And I guess the syntax for that is FF or F flush standard in. But that's why I wouldn't take that before. That if I remembered that when I was sitting here, but then I don't really remember why. But besides the fact that obviously the input buffer still contains like the new line from the previous one, but I don't know why it doesn't clear itself. Because we didn't have to do that when we brought in like two numbers, did we? It handled just fine. So I'm not sure why it does it on characters. And I got to pick up the pace a little bit. I'm only halfway through the PowerPoint here. Okay. SS scanf that reads us into the array of characters. So we got our %D and %LF bringing in X and Y, and then it formats it and puts it into that array of characters. I may not be remembering scanf correctly. I thought it overwrote what was already there. That implies that it doesn't. So that makes me curious what it is doing. Character S equals happy days. And intx double something y ss scanf s %d %lf %d %lf x y. And let's see. Doesn't override it. So how about if I put a number here, 22 and 33.5. I got something in there wrong, unless their code's wrong. printf at the end shouldn't matter. One, two, three, four, five, six. What goes along with that? Really wanted to see what it would do with the original string. I can see what it's doing here about the numbers, but oh well. Okay. String.h provides more functions. Here's string copy string s2 into array string s2 into array s1. The value of s1 is returned. This copies at most in characters. This appends. This appends at most in characters. So different functions. If you didn't use something like this, what you'd have to do is you write a loop for int x equals 0, continue while x is less than or equal to 4, x plus plus, and s2x is equal to sx, print s2. Notice what it did. It happy days, or happy and happy days. Why didn't it work? I went from 0 to 4, copying the first 5 characters. What's missing? String terminator, right? So really, I probably need this to be 6. And then down here, I would say S2 of 6, 5. 5 is equal to, let's see if I can remember the right slash. I think that one. We'll see. There, it worked. So that's what they're talking about, is you have to have that on the end. If you don't have that on the end, it just keeps pulling things out of memory until it runs into the first /0. Once it hits the first /0, then it stopped. But these libraries handle that for you, so it allows you to copy either all the string or parts of the string. I guess I lied to you. String in copy does not necessarily copy the terminating null character of its second argument. So does not necessarily copy. So you may have to check for that. Include the string.h header. That's kind of common sense. Not appending a terminating null character to the first argument of a string copy when the third argument is less than or equal to the length of the string, and the second argument is a common programming error, and it'll be obvious. Just like when I ran this, I knew what I'd done. When I was just printing the S2 and it was putting all of this in there too, I knew what it was doing in memory. It did not encounter that terminating the /0, so it just kept on printing everything. And let's see if I comment that out, and I have this equal to A. Get rid of that. I guess I can change that to 5 now. What do you think that's going to do? Print a lot of garbage, I'm guessing, until it hits the first /0 in memory. Let's see. Huh, that didn't go very far, did it? I don't know what that is, but it hit something in memory that caused it to stop. But since I did not put the /0 on at the end, it just kept on printing until it hit something that caused it to. How far will it go? I don't know. It probably depends upon where it's at in memory, what's beside it, and so forth. Okay. And again, they emphasize that /0 so much because, again, it's an important feature. And copies first 14 characters of X into Z, does not copy the null character. So Z is where it's being copied to. This is where it's coming from, and then this refers to the size. Size 2 is 15. 15 minus 1 is 14. Okay. Yeah, it's definitely, this is less than that. So it's not getting that /0. And that's why you have to tack on this /0 here at the end. You've heard of concatenate. I think this stands for catenate, but it pins it on the end. That's what concatenate means. First character of the second argument replaces a null /0 that terminates a string in the first argument. So you have to keep that in mind when you use this function. Concatenate first 6 characters of S1 to S3, and then it says place /0 after last character. And I don't see where they're placing the /0, so I think they're implying that the function itself does it. And I don't remember any of this when I'm programming. I just have to. I remember generally I'm looking up string functions. If you ask me next week, what's a string function for doing concatenation with so many characters? Couldn't tell you. But I know what to search it up for in Google. What would I search for? C programming string functions. Then once I narrow down to which one I'm wanting, then I'd probably put example on here at the end and try to look for a good example. Didn't used to be this way. It used to be programming was a lot harder. You had to memorize everything. Or you had these thick books, so you'd pull out the thick book, look through 200 pages, finally find the one what you're needing. Yeah. Now it's like 10 seconds later, and I have my answer. I know to calculate the length of a string, I'm going to use a string length. So, okay. That's also why I can't really give a whole lot of valid tests that aren't programming based, is because you can find the answer to something almost immediately. But every question that exists in every test bank is out there in some form, and even a lot of programming projects are out there in their complete form. Okay, here's some comparison ones. String compare compares this string with this string. Function returns 0, less than 0, greater than 0. If S1 is equal to, less than, or greater than S2 respectively. And again, this you have to take into account if you're dealing with the lowercase and uppercase, because that makes a big difference. And this one compares up to n characters of the string. We've got Happy New Year, Happy New Year. These, to me, they'll both look the same. So if you do the comparison of those, I think they come up equal. But Happy Holidays here. Happy is the same, space is the same. And then holiday, H in holiday is different than new, N and new. And you might assume that which one's greater and so forth. But it's based upon the ASCII table. Excuse me. When you're doing a comparison, it's comparing the decimal value. It's not comparing which way does it fall on the alphabet, though as you notice, these are in alphabetical order. But again, little a over here is 97, and E is 69. So little a is greater than big E. Common programming error, assuming that string compare and string in compare return 1 when arguments are equal to logic error. Both functions return 0. That's why I thought earlier. I thought 1 should be true. Strangely, the equivalent of C's false value for equality. I'll probably never get over that. Every other programming language I've ever run across is 1 for true, and for Boolean and so forth. But okay, this talks about Jones Smith. Okay. Talking more about the comparison. Numeric codes we've been mentioning. Search functions. String char locates first occurrence of character C in the string. String CSPN, what's that stand for? Determines returns the length of the initial segment of string S1 consistent of characters not contained. Okay. String SPN determines returns the length of the initial segment of string S1 consisting only of characters contained in string S2, and locates first occurrence in string S1 of any character in string S2. If a character from string S2 is found, pointer of the character in string S1 is returned, otherwise no pointer is returned. And I won't read those since quickly running out of time. This is an important one, I should mention. String token. Sequence of calls to string token breaks string S1 into tokens. Logical pieces such as words in a line of text separated by characters contained in string S2. First call contains S1 as a first argument. Subsequent calls to continuing tokenizing the same string contain null as the first argument. Pointer of the current token is returned by each call. If there are no more tokens when the function is called, null is returned. This is a way you can split apart a string. Like if it's separated by commas or spaces, you can split it apart. Talked about that. There's that one, searching for a character. Not equal to null. Null means I didn't find it. If it finds it, I think it returns the position, if I remember right. last occurrence. Length. I was looking for that token one. First occurrence of the second string argument and the first. Okay. There it is. Okay, our function string token is used to break a string into a series of tokens. Okay, we talked about that. There we go. Here we got a sentence, and it's separated by spaces. So there's a total of 1, 2, 3, 4, 5, 6, 7. 7 pieces. They call those tokens. And it just says the string to be tokened is this. And then down here, you got your token pointer is equal to string token. Then you got your string, and then your first space. And then while it's not equal to null, so you have to have this outside of your while loop. And then while it's not equal to null, you can go off here and retrieve those. And it splits it apart like that. The nice part about that code is, and if you have it handy there, you can grab it, you can Google it and find a copy of it and edit copy it, is you just need to make slight changes if you want it to be separated by commas, for example. I just replaced this space here with a comma. And this space down here with a comma. So it's pretty easy to modify this for your needs. Now they're not doing anything but special but printing off the token pointer, which is a string, but you can do other things with it also. Multiple calls to it are required to tokenize a string because the idea is you have multiple pieces to it. So you have to have it in a while loop. So while loop is you don't know how many you're going to have, so it can't be a for loop. Probably can't easily be a for loop. And this talks about your first call, the string to be tokenized, and then whatever your separator is. In this case, a space. And then your next call, or wait, this is their beginning one. That goes in a lot of detail about all that, if you're curious about it. Okay, memory functions of the string handling library. Now, these I've actually used very little. This is a different type of programming where you're using these functions. Memory copy, memory CPY, copies in characters from the object pointed to by S2 into the object pointed to by S1. Pointer of the resulting object is returned. Mem_move, copies in characters from the object pointed to by S2 into the object pointed to by S1. Copies performed as the characters are first copied from the object pointed to by S2 into the temporary array, and then from the temporary array into the final destination. Pointer of the resulting object is returned. And then memory CMP compares. Memory CHR locates the first occurrence of C. Memory set copies C into the first in characters of the object pointed to by S. The mem copy is more efficient than the string copy when you know the size of the string you are copying. May be more efficient, but I think it's more challenging trying to wrap your mind around what exactly is it doing. And they show you the example here. You got 17 characters here, so you're copying this. And you know how much you're copying. Memory move. String manipulation functions other than memmove that copy characters have undefined results when copying takes place between parts of the same string. This gives you the example here. And our compare. S1 and S2, they are different. A, B, C, D, they're the same up to there. So that's telling you what happens when you do your comparison up to certain characters. So again, you know what your number is you're looking at. That's curious. When you flip those around, I would have expected the same result. I'd have to examine that. Searches the first occurrence of a byte. Copies the value of a byte in the second argument into the first n bytes of the object. And a performance tip. String error. String length. That's one we just Googled. String error. What's that? I've used string length before. String error maps error number into full text string in a compiler in locale specific manner. Message may appear in different languages based on its function. A pointer to the string is returned. So I suppose if I had something where I had programmed it wrong and it dealt with strings, so this would give me a more meaningful error. Remember how I overloaded the stack earlier, and I was hoping to see stack overflow, and I didn't get it? It sounds like this is a more meaningful one. Like this, string error 2. Now they're not causing this to break or anything. They're just pointing out what is string error 2. Well, that means no such file or directory. And string length takes string as an argument, returns a number of characters in a string. Terminating null characters not included in length. This is something you could use to program like a while loop or a for loop. And it shows you the length of those strings. Again, doesn't include the /0. So if I was doing my loop, my for loop or while loop, and I loop from 0 to 3, I'd have to make sure that that extra, if I was copying characters, for example, that /0 should be in there. Okay, secure C programming. We presented these. More secure version of these and many other string processing and input-output functions are described by the C11 standards optional Annex K. We've been looking. There's weird things you can do with strings, isn't there? Array of characters. You can overload them. Exceed them. Among other things, more secure versions help prevent buffer overflows. That's why I was talking about overloading it. By requiring additional parameter, it specifies the number of elements in the target array, and by ensuring that pointer arguments are non-null. I can get away with programming sloppy. For 13 years, got away with it. Worked at Koch Industries, wrote internal programs for the accountants to use, managers to use. Worked at IFR. I wrote it for purchasing, shipping, production floor. Why did I not have to worry about all this secure programming?
Probably because programs are going to be used over the internet.
Yeah, that's where it really comes in. If you're going to be working for Microsoft and you're going to be having a package that runs on the cloud, if you're going to have something like you say, just runs over the internet in some manner, where an external individual can access your program, that's where you need to do a lot more worrying about it. It's nice to make everything 100% secure, but is it worth it? Yeah. Do I spend an extra 3 months on this when, who's going to hack into a Spectrum Analyzer? It's just like nobody to do that. Yeah. Now, if I'm going to hook up my electric generators, and they're going to have a C program running on them, I'm going to hook those into the internet so I can monitor them remotely. Well, then I don't want somebody to hack into those remote generators and shut down the cooling system. So that is more important there. So it all is based upon where you work. I never worked at a place where I had to worry about that. Okay, reading numeric inputs and input validation. It's important to validate data you input into a program, which I've ignored completely, as you've noticed. For example, when you ask the user to input integer in the range 1 to 100, then attempt to read that integer using scanf, there are several possible problems. User could enter an integer that's outside the program's required range, an integer that's outside the allowed range for integers on that computer. That's a bigger issue. You can just do an if statement to see if it's in that range, but if it exceeds the capacity of an integer, then it causes other problems. Or a non-integer numerical value or a non-numeric value. And you can use various functions that you learned in this chapter to fully validate such input. For example, you could use fgets to read the input as a line of text, convert the string to a number using a string to long integer, I think is what that was, or long, and ensure that the conversion was successful, then ensure that the value is in a range. This is a big one here. Read the input as a line of text. Then you got an array of characters you can work with. And you can do everything under the sun. You can go through character by character, checking to see. Remember all those functions? Is this an alpha? Is this a numeric? So you can do a lot of checking on that. You can check the length of it. If it's all numbers and the length of it's 500, that's probably exceeding the limits of an integer. And so you wouldn't want to write that out to an integer. So that's a big one right there. And for more information, good techniques for converting input numeric, see CERT guidelines. So, is there any questions on any of that? Well, I'm going to go ahead and stop the recording there. Don't forget you have the test. I really do want to show you some meaningful programs dealing with strings. But I want to combine that with another topic. So I'm not going to actually assign any programming projects out of this chapter. So if you want to practice, I encourage you to. That's the only way you get good at programming.